So the book, Tony McMichael's, basically uses words to summarize what we discussed and the relations between climate, humans, health, and then what the future is in terms of emissions, actions needed, sustainability, and so on. So what I did was instead take few figures to summarize the points in my own way. So starting with this quote from the book, trend is not destiny, right? So we are on a trend of burning fossil fuels, warming the temperatures this way, and obviously if we continue business as usual, we would be in deep trouble. Warming could be in this range or even higher. But if you see the action, especially the negotiations under the UNFCCC, the United Nations Framework Convention on Climate Change, all countries are at the table committing to the so-called nationally determined contributions to reducing emissions and so on. And one could argue that despite the 25 years of negotiations, we are still on this trajectory of business as usual. So renewables are growing, electric vehicles market is growing, people are more aware, corporations are willing to commit to sustainability and reducing emissions and so on. And when will we actually see a turn down of the total emissions? Because even after that happens, the accumulated carbon will continue to warm for some time. So those are the kind of issues one has to worry, because all that affects food production and health, of course, directly, right? So here are global greenhouse gas emissions and warming scenarios. These are the numbers in gigatons of carbon dioxide equivalent, which means we convert methane, nitrous oxide, HFCs, the refrigerants, and so on, into CO2 using chemistry and what is called global warming potential, how strong global warming agents they are compared to carbon dioxide and so on. So I have podcasts on that you can look at. So looking at the historic trajectory from 1990 to about 2015 or so, this is the emissions we would get, and those are the warming ranges we would expect if we did not take any action and had no climate policies. But obviously, as we said, current policies are already trying to pull it down to about emissions below 50 gigatons per year, and the current policies will only get us down to 2.7 to 3.1 degrees C. You think that would be impressive, but actually in terms of the impacts estimated based on past climates and also some political considerations of where these kind of 2 degrees centigrade targets came from, mostly from Bill Nordhaus, an economist, and then Stern Report, European Union, and so on. So not completely scientific goal, but nonetheless it gives us a target. So let's say we want to hit 2 degrees C or 1.5 degrees C with some 67% probability. Then you have to start drawing down carbon. But the pledges that have been made under Paris Agreement, the so-called nationally determined contributions that I mentioned, bring this current policy targets down just by a tiny bit, which is still not sufficient. So the question then is, what are the options we have of pulling down carbon and going so-called net zero at some point to hit these targets? 2 degrees C was determined to be a good target, and then a special report was released by the UNFCCC, and it argues now that maybe 1.5 degrees C is much safer. Okay, so without going into details, these are the kind of issues we are dealing with for the future. We said food and climate are together are the big factors affecting human health: malnutrition, starvation, famines, droughts, floods, etc. Right? Of course, agriculture also relates to water quality and air quality to some extent. This is a report from this management consulting firm, so I'll just use it as an example of how agriculture itself can plan for the future without even worrying about health, but just about meeting the food demands of the growing population with the projections that we talked about before, where maybe we are overestimating considering the trends in fertility rates and so on because of educating women and their financial independence. So here is a map of technologies and maturity. They give three big sectors here: producing differently using new technologies. So agriculture has to find new technologies, use new technologies to bring food production to consumers, increasing efficiency in the food chain, so reduce loss, waste, and emissions there. Incorporate cross-industry technologies and applications. So examples in each here, for example, hydroponics, which is now shown to be successful at some small scales. The question is how large can it get? Algae feedstocks for biofuels, for example. Algae can be grown to sequester carbon, and that sequestered carbon can be converted into energy. So you're trying to produce not only carbon neutral fuels from these kind of sources, but algae can also now some marine plants have also been shown to reduce methane emissions from cattle as when they're fed that as feed, for example. Bioplastics, there are controversies because many of the bioplastics are being coated with things which make them non-biodegradable, so that has to be kept in mind as well. And you have going forward in time here today to future with readiness to grow to market size, desert agriculture and seawater farming. So ocean farming is also already demonstrated, provides a nice 3D space on which you can grow clams, marine grasses, scalps, seaweeds, other things. In new technologies to reduce transportation and increase efficiency, we have vertical and urban farming, which is happening at some scale. So it is not yet completely ready. So in terms of readiness to grow to market, we will need probably combine these with genetic modification. Controversies again abound in terms of people's perception of GMO seeds and technologies, which is mixed in with corporations trying to control the market for seeds and so on. Cultured meats are being produced in the lab now, for example, from vegetables, and 3D printing of certain kinds of foods. Cross-industry technologies and applications. Drone technology, data analytics, Internet of Things, precision agriculture. So there are already funds being given to universities and consortia of universities, farmers and corporations to use these technologies to advance precision agriculture, to reduce fertilizer use, water use, improve crop choices, reduce pollution, and improve yields, of course. In the future, we will obviously get into nanotechnology, artificial intelligence, food sharing and crowd farming, and blockchain technologies. Blockchain technologies are now being used to reduce water wastage, water use, groundwater monitoring, and so on and so forth. So this sounds a little futuristic or maybe too general, but there are specific examples where these things are working. The other one that I like, maybe I should leave it for the next podcast since this is already about 9 minutes, but you get the idea that we are on this inexorable path of warming the climate by increasing fossil fuel emissions and greenhouse gases. The future of climate and human health must tackle emissions reductions, agricultural production, and other behavioral changes as well that we will see. Plus, we will talk about what are called broadly as climate adaptation and mitigation, and then we'll also look at some options for health adaptation and mitigation. So again, remembering from before, all these sectors cannot now be dealt with separately. You cannot worry about For example, improving agricultural emissions reductions without worrying about how that may affect water quality, air quality, and climate. And health, of course. Okay.